In this video, I will explain you what will happen when a pure capacitor is connected across an AC power supply. So we have a capacitor, it is connected across an AC supply. So we know what is an AC input, right? So AC in an AC input. So this is, in this case, it is output. That output is connected across a capacitor. Now what would be an AC output? AC output would be in this way. So this is the variation of EMF. So in the first half, that is till T by 2. The whole cycle is the time period T and half of it comes here. Okay. Till here, the current is in one direction. Okay. Then current reverses the direction. So what will happen in these two cases across capacitor? Now when current is in one direction, means polarity here would be positive and negative from here till T by 2. So at that position, this will, positive charges will keep on be adding. So charge will get accumulated here, positive charges. So the value of charge will increase to a maximum value. Now from there, the positives will decrease. So initially this will be the case, positive here and negative here. Now initially, see, charge will increase and become the maximum value, then charge in the capacitor will decrease and becomes zero value. How can I say that? Q is equal to CV. Okay, now voltage start increasing from 0. Okay, from here. Now when voltage increases, C will not change, but Q will also increase to a maximum value. Now voltage decreases and comes to 0, and Q will also come to 0. Now in the next cycle, what will happen? This polarity will be changed. This will be negative and this will be positive. Now see, negative charges will keep on increasing here and positive charges at this position. So that will become maximum here, then negative charges will decrease here and comes to 0, and also positive charge will decrease. So what will happen? Positive will increase here. Now positive will decrease. So positive increases, decreases. Now opposite, negative increases, decreases. This is the change that is happening in this circuit. Now anyway, we know that the charge Q in the capacitor is increased and decreased. So there is a rate of change of charge here, right? And what is rate of change of charge? dQ by dt is nothing but current. And we know that, see, if the frequency is 5, now this is 50 times charged and discharged, and charged in opposite direction and discharged. 50 times in a second that will happen when the frequency is 50. So in a one curve, charged in one direction, now discharging, now charged in other direction and discharging. This will happen. So charging in one direction and charging in opposite direction will happen in one cycle. Now 50 hertz means 50 number of cycles will be there in each second. So this will happen 50 times in each second. Okay. So if we are finding dQ by dt from this, we will get the value of current. Now we will do that. So Q is equal to CV. And C will not change, and applied value of V or E is nothing but E0 sin omega t. So instead of V, I will mention it as E0 sin omega t. So that is V. Either you can mention it as here or Vm sin omega t. Both are same. Sin omega t. V is potential difference and that is nothing but EMF. Both are same here. Okay. Unless we are not considering internal resistance, we could say that Vm is equal to voltage potential difference or terminal voltage is equal to EMF. Both are the same. Okay. Now here Q is equal to this, and dQ by dt is the current, and that would be is equal to d by dt of this C E0 sin omega t. Omega this is C, and E0 will come out d by dt of sin omega t. Now C E0 d by dt of sin theta is equal to cos omega t into omega. So this is current. Now see, all these values are constant, so I can say that Im cos omega t. But now I can't draw the phasor diagram because my voltage is a function of sine and this is function of cos. Okay, so we need both in the same manner. So I have to convert this into sine function. So cos omega t can be written as sine omega t plus 90. See, sine 90 plus theta and sine 90 minus theta both are is equal to cos theta. Either you can convert cos theta as sine 90 minus theta or sine 90 plus theta. But if you are keeping minus theta, you know, what will happen? Inside here this will be 90 minus omega t. So we can't compare. Here it is plus omega t, here it is minus omega t. So we will choose the one which is in the similar way as compared to the input signal or input EMF. So I am going to represent this as sine, this is omega t plus 90, I is equal to. See, when EMF is at omega t angle, now this phasor current would be omega t plus 90. So here it is always plus 90. Whatever may be the value of 90, this will be whatever may be the value of omega t, this would be 90 degree forward. So I can say that in capacitor current leads voltage by pi by 2 radians or 90 degrees radians. Okay, that is the representation of this. Now we need the phasor diagram and the wave representation. So phasor diagram is very easy. We got both the values. Okay, and this is voltage, and that is making omega t in that is making an angle of omega t in counterclockwise direction from x-axis omega t, and this is E0. And its x representation or y projection it is, that is E0 sin omega t. See, I got this value input. Now we know that current is leading by 90 degrees, so current will comes here and that value will be 90 degree forward from phasor E0. This is I maximum and its projection on y-axis is I0 sin omega t. Now this is my current at any moment, instantaneous current, and this is my voltage, instantaneous voltage. How to represent it on a curve? Voltage would be leading, so this is voltage. Sorry, current is leading here, but voltage is our input, right? So always we will start from 0 and go to maximum value 0, go to maximum value in opposite direction 0 in this way. Okay, now I will draw the table theta I E 0. So sin 0 is equal to 0. But what will be the case of I? Omega t is 0, sin 90 is 1, I will be Im. Now next is 90 degree. Sin 90, 1. So this will be E0 itself. So here 90 plus 90, 180. Sin 180 is 0. So this will be 0. Now 180. This is 180 plus 180. Sin 180 is 0. Now here 180 plus 90, 270. Sin 270 is minus 1, minus I. Now 270. Oh yeah, this is enough. Okay. So I will start from, when EMF starts from 0, I will start from Im. So this here will be Im. Okay, maximum value. Now from here, this is 0. At 90, that will be 0. And at 180, that will be minus 1. At 270, this will be 0. And here, that will be, yeah. In this way, this will go. This is the wave representation. This is for current Im sin omega t, and this is Im or I0 sin omega t. Both are same. Now this is Em or E0 sin omega t. See, both are same. Em and E0 represents the maximum value. Okay. Now we got the phasor diagram, we got the value of current, we got the value of EMF, we got the wave representation. Now we need the capacitive reactance, because in the previous case we got inductive reactance, right? So we need, from here I know I0 or Im is equal to C omega into E0, and we know that I is equal to V by R. Now V divided by R, and this R will be my resistance or reactance, but we have nothing divided with E, we have something multiplied with this. So how to convert this in the standard notation? This can be E0 divided by 1 by C omega. So it's the same thing, C omega will come to the numerator and it would be C omega E0. Now I can say that this comes in the same position of resistance. So as we have capacitor here, I am going to call this as capacitive reactance. Capacitive reactance. And the value is 1 by C omega. Now here in this case, when frequency of the current increases, C omega increases and capacitive reactance decreases. So for AC will choose to go through capacitor, or capacitor will offer very less opposition for the flow of current, because when frequency increases the total value decreases and the reactance decreases, that is basically the opposition towards current. But what is the case of inductor? In inductor, L omega is the reactance. So when frequency increases, the L omega reactance increases, resistance increases, and that gives more opposition to the flow of current. So inductor blocks AC current and capacitor allow AC current to pass through. Okay.